one day soon, man is going to be able to harness incredible energies, maybe even the atom. Energies that could ultimately hurl us to other worlds in some sort of spaceship. And the men that reach out into space will be able to find ways to feed the hungry millions of the world and to cure their diseases. They will be able to find a way to give each man hope and a common future. And those are the days worth living for. Our deserts will bloom.
Development of atomic power is years away. Space flight years after that.
Being able to harness nuclear fusion would be a breakthrough for mankind. It would change everything about the way we live. It is the holy grail of energy. It's clean, it's unlimited.
Annie Kritcher is leading the quest for this holy grail. She's a nuclear engineer, physicist, and lead designer of fusion experiments at Lawrence Livermore National Laboratory. There she tries to recreate the same reaction that powers the sun and other stars. Intense heat and pressure can make two atoms fuse together into one, releasing energy. The process doesn't produce greenhouse gases like fossil fuels do, or radioactive waste like the nuclear fission or splitting reaction used in today's nuclear power plants.
The fuel source is forms of hydrogen. One of them you can find in seawater, and the other one you can breathe through interactions with lithium. Estimates are that for one person's lifetime, you'll only need a bathtub of seawater and one laptop's battery worth of lithium.
Wow.
But before that happens, scientists have to learn to achieve fusion ignition, getting more energy out of a fusion reaction than it takes to start it. They've been trying to do that worldwide since the 1950s. Here inside the 10-story high National Ignition Facility, they've made more than 170 attempts by bombarding a tiny fuel pellet with the world's biggest laser.
We have the biggest laser in the entire world, 450 terawatts, 1.9 megajoules, actually up to 2.29 megajoules now. Once the laser energy comes into the target chamber, it hits a target or a hollow can that's made up of gold-lined depleted uranium. The lasers actually hit the can itself. That creates an X-ray radiation bath, so an X-ray oven that's about 3 million degrees in temperature. So the X-rays heat up the outside of a pellet that sits inside of the can. It's a hollow pellet. In our case, it's made up of diamond. And then inside of that pellet is the fuel, the deuterium and tritium fuel that we're trying to fuse. The X-rays heat the outside of the pellet, and it's just like a rocket. The rocket fuel goes out, the rocket goes up. So here we expand out that pellet material outward, and that causes the rest of the material to squeeze down, and that's what causes the heating and compression, because you're taking something of a big volume and squeezing it down to a really tiny volume. The pellet is 2 millimeters roughly, so it's about the size of a BB, sitting inside of the can, which is about 1 centimeter, about the size of a pencil eraser. We take that BB-sized capsule and we squeeze and compress the plasma down to half the width of a human hair.
But after decades of work around the globe, no lab had ever achieved ignition. Kritcher and her team kept fine-tuning thousands of parameters in their experiment.
Our job is really, what are the optimal target conditions and laser conditions to create the right plasma physics, to get the plasma hot enough and dense enough and confine it for long enough, because we need to create star-like conditions to actually generate more fusion energy out than what we put in.
And on December 5th, 2022, they succeeded.
The first breakthrough experiment was 5 times hotter than the center of the sun, actually more than that
5
now.
times hotter than the center of the sun, here in this facility.
Yeah, so the most extreme place in the solar system.
Wow.
Time magazine named Kritcher one of the 100 most influential people in the world in 2023. Now she and her team are working on the next steps toward the ultimate goal of clean energy.
We're trying to compress the pellet better. We're trying to hold it together longer so it burns up more of the fuel. We're actually only burning about 7% of the fuel that is in there. What would need to happen to commercialize this source of fusion energy, since it happens, there's extreme amounts of power. It's like over 30 quadrillion watts. but for a very short time period. So what we would have to do to produce enough fusion energy is have this system be pulsed. It has to be a pulsed system. And we also need to continue to increase the gain out. So right now, the fusion energy that we produced out isn't enough for a working fusion plant. We need to increase that by about another factor of 30.
If we put a lot of resources at this, added many bright minds like yourself to work on it, what might be the earliest that we'd be able to see this commercialized?
If we could move faster and have unlimited resources, it could be within the next 1 to 2 decades.
Wow, fantastic.
For her efforts in bringing the future closer, Annie Kritcher is a 2024 Genius Award recipient.